2. Standards for the testing of electronic EE system. 1. Automotive SPICE. A SPICE process improvement follows the approach that the quality of a system is influenced by the quality of the development process. Process models offer an option for improvement by measuring the process capability of an organizational unit or project compared to the reference model. Furthermore, the model served as the framework for the improvement of the processes of an organizational unit and or project using the assessment results. Since 2001, the SPICE user group and the Automotive Special Interest Group (AutoSys) developed a SPICE. Since 2005, the standard has been well established in the automotive industry. All statements made in this paragraph refer to a SPICE version 4.0. Design and structure of the standard. The two dimensions of a SPICE. A SPICE defines an assessment model with the two key dimensions of assessment. In the process dimension, a SPICE defines the process reference model (PRM). The process reference model served as a reference to compare the organization processes against it, so that they can be assessed and improved. For each process, a SPICE defines the purpose, the results, the required action, best practice, and the information items, work results, and work products. In the capability dimension, a SPICE defines several process attributes, measurable characteristics, that define the capability level. For each process, there are various and process-specific attributes. ISO IEC 33020 serves as a basis for the assessment of the process capability. With the help of this model, it is possible to assess the process dimension regarding their capability dimension. Process categories. In the process dimension, a SPICE categories processes into groups, which are further classified into categories. The primary lifecycle processes includes all processes that serve as key processes. Acquisition process group, supply process group, system engineering process group, software engineering process group, machine learning engineering group, process group, hardware engineering process group, validation process group. The supporting lifecycle processes includes all processes that support other processes. Supporting process group. The organizational lifecycle processes includes all processes that support the company objective. Management process group. Process improvement process group. Reuse process group. For the tester, the process group system engineering and software engineering are of special interest, possibly also the machine learning engineer, validation engineer, and hardware engineer. Capability levels. In the capability dimension, the accessor accesses the process capability with the help of the six-level assessment system display of levels. A SPICE defines the capability levels 0 to 3 as follows. Level 0 in complex process. The process is not implemented or fails to achieve its purpose, its process purpose. At this level, there is little or no evidence of any systematic achievement of the process outcome. The process does not access or does not achieve the purpose of the process. Example, the tester only checks a small part of the requirements. Level 1 Performance process. The implemented process achieves its purpose, but may be executed inconsistently. Example, there is no complex planning visible for the test process. However, the tester can show the level of fulfillment of the requirements. Level 2 Manage process. The process plans and supervises the test process in its test execution. Under certain circumstances, it adapts the course of action during test execution to meet the test objectives. The requirements for the work products are defined. A project member reviews the work products and approves them. Example, the task manager defines the task objective, plans the task activities, and manages the task process. This includes reacting to deviation accordingly. Level 3 Establish process. The process uses a standardized test process, and findings are used for constant improvement. For example, there is an organizational test strategy. After test completion, the test manager works to further develop it. Requirements of the standards. Test specific processes of a SPICE. A SPICE defines test processes according to all processes of the software and system development, software unit verification, revise status testing, and dynamic testing. It accesses the components of the software based on its detailed design, software component verification, and integration verification. Access the integrated software beyond the software architecture design. Software verification accesses the integrated software beyond the software requirements analysis. System integration and integration verification access the integrated system beyond the system architecture design. System verification accesses the integrated system beyond the system requirements analysis. Rating levels and capability indicators. An accessor can assess the process capability via capability indicators. A SPICE defines them for 9 process attributes. For the capability levels 1 to 3, they are defined as follows. Process attribute 1.1 Process performance process attribute. The tester is oriented in test process. Process attribute 2.1 Process performance management process attribute. The tester plans, supervises, and controls the task activities. Process attributes 2.2 Process work product management process attribute. The tester checks the quality of the testware. Process attribute 3.1 Process defining process definition process attribute. The person responsible for task process defines an organizational task strategy. Process attributes 3.2 Process deployment process attribute. The tester applies the task strategy defined in process attribute 3.1. For the process execution, a SPICE defines 2 types of capability indicators: base practice and information item. In addition, generic practice and resource are defined. The assessment of the process attributes is based on the implementation level of the indicators as for rating levels: not fulfilled, partly fulfilled, largely fulfilled, fully fulfilled. For a process to reach a certain capability level, the capability indicators must be achieved either largely fulfilled or fully fulfilled. 3. Test strategy and criteria for regression verification. A SPICE requires a test strategy verification measures for each task process, starting with capability level 2. The task manager develops it during the task planning. Task guidelines, process objectives, and contractual and regulatory requirements form the basis for it. The tester is aware of early testing as a principle of testing. This also applies to the testing of software in the automotive environment. However, another aspect comes into play here because test environments at the higher test levels are significantly more expensive. For example, for testing at higher levels, especially developed and embedded hardware is necessary as a prototype or unique model. Test strategy defines the level-specific test environments, but also which tasks the tester is required to perform in which test environments. The criteria for regression verification are an essential part of the test strategy. They specify the details for the regression verification. The challenge lies in the economically sensible choice of the test case. Add value of testing. The criteria for regression verification define the test objective and the test approach for the choice of the regression test. For example, the choice can be risk-based. An impact analysis helps to identify the areas the tester must focus on which regression test. However, the task manager may also ask the tester to repeat or automate the case for each release. Testware in ASPICE. ASPICE 4.0 does not impose requirements on testware. Instead, it establishes requirements concerning the documentation of specific information that arises during testing. For test activities, ASPICE requires the task following information items: verification measures, simulation, dynamic tests, and static tests, typically documented in a test plan. Verification results, documented verification logs, test reports, and defect reports. For each information item, ASPICE defines examples of information item characteristics and content. They serve as an objective indicator for process execution. ISO, IEC, IEEE 291193 can be used to further structure information item. Verification measures for software unit verification. The tester verifies compliance with the software detailed design and with the function and non-functional requirements according to the verification measures. The measures define how the tester provides the evidence. The tester can use a combination of static and dynamic techniques to verify the software units. In software engineering best practice, ASPICE revised the definition of the verification measures for the verification of software units. This allows the tester to assess the extent to which the software unit meets its requirements. The following examples could be used as software unit verification measures. Software unit test case, including test data. Tool supported status analysis, which assesses compliance with coding guidelines. C. Reviews for software units or parts of software units, which cannot be accessed by tool-supported status analysis. If a developer changes a software unit, the tester must also evaluate this change. Therefore, the verification measures of software units also include the criteria for regression verification. This includes the verification of the trend cause, the confirmation testing, and the repeated verification of the non-trend paths, static and dynamic regression tests.